All right, so I hope you guys can see it. But example 2 says we're going to find the probability of getting no more than 3 bad apples. So guys, we're talking about bad apples again. So we're still using the same N and the same P here. So before we actually get into work, we're going to go and pull these back, because that's the same ones that we had for example 1. And we're using that for example 2, and we're going to use it for example 3. All right, so it says find the probability that of getting no more than 3 bad apples. So here, what we're looking for, and I didn't do this for example 1 because we had other work to do. So this time we already have the P and the N, so we're going to do this part. So we say no more than 5. No more than 3 bad. All right, so if we say no more than 3, what does that mean again? It's like when we talked about at the very beginning of the lesson. No more than 3 people in the classroom. That means it's going to be 3 or less, which is 3, 2, 1, 0. So 3 or less. So like, okay, cool. All right, so let's go ahead and go back to Desmos real quick. See what we're going to put in there. Let's write it out. We got 10 inside, 0.05. Here, we're looking at our min and our max. Our min would be 0 because that's the smallest number here. Our max would be 3. That's the highest one. So here, we're going to put in 0. We're going to put in 3. So 0 is here, 3 is here. And when we come into Desmos, we're going to follow the same process and do that. So we get that, get functions, distribution, binomial distribution. We put 10 here, comma 0.05. Close that. All right, and just real quick, I didn't say it for the first one, but if you guys remember, like earlier, like a few weeks back, about a week or so back, we talked about a thing called normal distribution, bell-shaped curve. And that looks like a bell-shaped curve right there, right? Yeah. So with that, as we're going through this, we're going to pull back in bell-shaped curves, the normal curve and everything. But you'll be able to see here that when we start talking about specific distributions, binomial distributions and what pieces of it, it's going to highlight this when we do this over here. So that way we can get an idea of like what we're really adding up, what's really happening. So we have 0 here, we have 3 here. And we say, okay, that's a really good number. That's a really like solid number there. So our probability now with this part, before we go in, everybody should be able to do this again. Remember that 7 takes that 9 to go up. And as you see, we're rounding 4 decimal places each time. 4 decimal places. So that 7, sorry, not the 1, but the 7 takes the 9, makes it go up to 10. So that 10 will make that 8 to go up to 9. So we have 0 there. All right, so our percentage, if we change that from the decimal to the percent for the probability, and make sure you can do both, it should be 99.9%. And again, what does that mean? Because again, we don't care really about just that you get answers. We care about what those answers mean. Like what can you explain what those answers really mean? And so here, that's what we did. That's what we're going to do. So let's unload this part here. So there's a 99.9% chance of no more than 3 apples being bad or having a worm in it. Easy, guys. It's easy.